Hello, everyone. Today I am very excited to talk to you about our recent work, MetaCloak, where we try to protect images from unauthorized generative AI training. Our work is built on the background of the diffusion model's customized training, which shows really powerful few-shot generation ability. However, it's also being largely misused. For example, the deepfake technique empowered by diffusion models poses a threat to the digital portrait rights of each individual. Public celebrities are largely affected by this due to the abounding portrait images online and the significant benefit from illegal synthesis. Moreover, it also brings copyright infringement to artists due to the presence of style mimicry empowered by diffusion models. This issue not only causes significant financial losses, but also hurts the motivation of a lot of artists. For example, a famous American singer named Taylor Swift became a victim of deepfake-based pornographic imagery synthesis. One of the potential methods to achieve that is to train personalized text to image diffusion models on the collected portrait image and inference with unsafe prompts. What's even worse, each individual can be the victim of such privacy invasion due to the prevalence of social media. Attackers can even launch defraud with the fake images. Another important example is artwork style mimicry. A professional artist named Kelly McKernan found that over 50% of her paintings were scraped into the Leon 5B database with no consent. As a result, she has filed a lawsuit against Stability AI, the company behind Stable Diffusion, to protect her artwork copyright. To tackle these issues, recently studies found that data poisoning has become a promising approach for battling against this kind of unauthorized synthesis. By adding some imperceptible protective perturbation into the data, the fine-tuning process can be perturbed and the generated images will be pretty noisy, hindering their usage for other malicious purposes. Formally, the main idea of this direction is to perturb the clean training data by adding some noise such that the models trained on the perturbed data will have poor generalization performance. The underlying mechanism for this attack lies in the shortcut learning preference of DNN models, where they turn to rely on some easy but brittle patterns for prediction. Besides typical classification models, personalized diffusion model training also exists, such as a vulnerability that might falsely link the concept token to the injected perturbation. However, we found that existing works like Glaze and Anti-Dreambooth fail to be robust against minor data transformation defenses and are brittle when training across different diffusion models. To tackle these limitations and make that protection more realistic in the wild, we propose a more robust poisoning approach called MetaCloak, which is based on the perturbation surrogate alternate updating framework. First, we propose to solve the bi-level poisoning problem with a meta-learning framework. Specifically, we employ a pool of surrogate diffusion models to craft transferable and model-agnostic perturbation. Due to the diversity of surrogates in terms of initialized weight, the transferability of the perturbation is greatly improved. Second, rather than crafting noise to disturb the quality assessment metrics, we find that maximizing the denoising loss can be a more robust approach to bringing in meaningless and hard-to-understand patterns that fool the diffusion models. To enhance its resilience against transformation, the perturbed images are smoothed and purified during the crafting process. We mainly test our method on two facial datasets in this paper, Saliba HQ and VGG Phase 2. We use 5 metrics to measure the generation performance of models trained on perturbed data, including identity, similarity-based scores, and graphical quality-based scores. We consider 6 state-of-the-art baselines. Please refer to our paper for more details. For effectiveness comparison, we found that MetaCloak outperforms other SOTA methods under the transformation training setting in terms of all metrics. Our visualization, we found that other perturbations fail to be robust when applying data transformation. We also validate the effectiveness of MetaCloak on a popular online training service Replicate in both full and LoRa fine-tuning settings. We validate the transferability of MetaCloak across 3 different versions of stable diffusion, ranging from SD v1 to 5, v2 to 1 base, and v2 to 1. For advanced purification, we found that defenses like super resolution can break the perturbation but still can't fully retain the clean generation performance. In the ablation study, we found that the EOT term contributes more to the performance gain, and combining both modules yields the best result. We also visualize and analyze the perturbation learned by MetaCloak and previous SOTA methods. We find that high-frequency signals matter for tricking the models into overfitting. In conclusion, in this work, we propose MetaCloak, which provides a more robust poisoning-based approach to mitigate unauthorized training and image synthesis. It works by injecting delusive perturbation crafted from an ensemble of surrogated models with meta-learning and transformation-robust denoising loss maximization. Notably, MetaCloak is adaptable to any set of differentiable transformations and any set of diffusion models to further release its power. Thank you for listening.